Hello, so I'm going to explain the problem 5 of MEXT Physics 2017 Undergraduate. So the problem is two small speakers at point A and B is separated by 6 meters. An observer listens to the sound from the speakers at a position along a straight line PQ, so it's this line, which is parallel to and separated by 8 meters from the straight line AB. A point O on PQ is at the same distance from A and B. So O is at the center of the distance of A and B. The observer moves from O towards Q. So O to Q here. The position of the observer is described by X. So it is X. At O, the observer hears the sound of constructive interference from the two speakers. As the observer moves from O, the sound becomes weaker. At X is equal to 3m, the observer hears the minimum sound for the first time. So blah blah, the speed of sound is 340 meters per second. Answer the following questions. So number 1, find the wavelength of the sound wave. So before solving this problem is that you have to know that when there is two sources of waves, so it can be light or sound, and at point P we want to know that it is constructive or destructive. So at point P we want to know that the wave of S1 and S2 is constructive or destructive. So we can find whether it is constructive or destructive is by knowing that the path difference, so the difference of the distance from S1 to P and difference from S2 to P, is for constructive case, it is the multiple of lambda over 2. It is the even multiple of lambda over 2. And it is destructive at point P when the difference and when the path difference of S1P and S2P is the odd multiple of lambda over 2. So we can write even multiple or odd multiple as 2m and 2m plus 1, where m is equal to 0, 1, 2, 3, and so on. And it is in case of in phase, and for out of phase it is the opposite. So from the problem we know that the sound becomes from the problem we know that the observer hears the minimum sound for the first time. So it is the destructive. So it is destructive. So at x is equal to 3, it is destructive. So we can write this. So the difference of the distance between A, so we call this P, not to confuse with this P. So the difference from the distance difference from A to P and B to P is equal to the odd multiple of lambda over 2. And since m is equal to 0, 1, 2, since it is the minimum sound for the first time, we use the first index, that is 0. So 2m plus 1, m is equal to 0, it became 1. So 1 times lambda over 2 is lambda over 2. And to find the difference of the distance from AP and BP, we know that this to here, O to this line AB, is 8 meters. So the distance from A to P is 8 meters. So we can write AP is 8. And to find the distance from B to P, we know that A to P is 8 and the distance from A to B is 6. So from the Pythagorean theorem is that can know that 64 plus 36 square root is 64 plus 36 is 100, and when it's square root it is 10. So we can know that the distance b to p is 10, and 8 minus 10 is equal to 2. 8 minus 9 is minus 2, and since there is an absolute value, it is equal to 2, and 2 times 2, so the 2 moves here to here, so it is multiplication. 2 times 2, it is equal to 4, so the wavelength is 4 meters. So the answer is B. Number 2, find the frequency of the sound waves. So we should know that the velocity is equal to lambda times the frequency, and we can write we can move lambda to here to the bottom of v, so it became v is equal to v over lambda. And from the problem we know that the speed of sound is 340, so we can write 340, and from number 1 we know that the wavelength is 4, so 340 over 4 is 85, so the answer is B. Number 3, so as the frequency of the speakers is increased, the observer at x is equal to 3m experiences an increase in the sound. Further increasing the frequency, the sound reaches its maximum and then decreases and finally returns to its minimum again. Find the closest frequency of the sound wave when the sound reaches its minimum again. So we know these two equations, and from the problem the frequency increases, so as f increase, lambda decreases, so lambda is inversely proportional to f, and as lambda decreases, since the distance is still, the x is still 3, so the AP minus BP is still 2. To catch up, the 2m plus 1 should increase, and the closest frequency is when m is equal to 1. So the first one, m equals 0, so the one that is closest to m equals 0 is m equals 1. So 2m plus 1 when m is 1 is 3. So we know that, so we can write this equation: 2 is equal to 3 lambda prime over 2, the lambda after, add the lambda in this case. So the lambda when the frequency increases and when it reaches its minimum again is 4 over 3, and it is the third of the wavelength that we found before, so we know that it is the case when the frequency is multiplied by 3, and we know that the frequency is 85, so 85 times 3 is 255, and to write this in two significant figure, it is 2.6 times 10 to the power of 2, so the answer is E. So the last question, number 4, the frequency of the speaker is fixed at the value of problem 2, so it is 85. Find the correct description for the change of the value of x at which the observer hears the minimum sound with the temperature of the air increases and the speed of sound in the air changes. So from these two equations again, when or as the temperature increases, the speed of the sound increases, and when the speed of the sound increases, the wavelength is increased. So from this equation, and as the wavelength increases, the difference of the distance from AP and BP increases too. So as AP and BP increases, X increases. So we can conclude this because uh, when, uh, when X increases, the A, so let's let it this point, it is oh yeah, the B, the small distance increases, is more meaningful to the distance of B to P than A to P. So we know that the difference of this distance increases. So you know that the distance X increases. So the answer is A.